Hi, and welcome to Z-Size. From the project, you can begin working on an individual sizing by clicking on Sizing 1 here and what I'll call the tree on the left side. Now we're ready to begin working on a sizing calculation. At the very top, we have the same Help Request button again, just like on the project page. The note here means that by hovering your mouse over some of the line headings, you'll see a brief description of what that particular line means. For example, Solve for shows a box, as does sizing code, fluid state, and so forth. In the sizing info line, the project name is populated from the project page. The tag number is a field that you can fill in that refers to your rupture disk application. For example, I'll type in a PSE number and tab off of that field. Notice that in the tree, you can now see your tag number reference. The revision number field can also be filled in with whatever reference you would like, and its entry will append to the tag number displayed in the tree on the left. Next, we have the choice of solving for MNFA or capacity. If you choose MNFA, you will enter capacity values and the calculator will show an MNFA result. If you choose capacity, you will enter an MNFA value and the calculator will show a capacity result. In this example, we'll solve for MNFA. Sizing code is the next line, and Z-Size offers 3 calculation standards: API, ASME, or ISO. While the required information is similar, the 3 codes do use slightly different formulas for their calculations, which we can see later displayed on the printout. Next, we will choose the fluid state. The 3 options are gas, vapor, liquid, or steam. The combination of sizing code and fluid state will determine which of the standard formulas Z-Size will use in its calculations. All of the calculations in Z-Size are based on a sizing method using coefficient of discharge, also referred to as KD. The next line has fields for purpose and relieving case. The combination of these choices will set the overpressure allowance, seen here on the next line. The next line is where we will enter the required capacity. The first field is numeric, followed by a capacity unit of measure. Clicking on the drop-down will show several units of measure to choose from, depending on the fluid state, whether it's gas, liquid, or steam. In this example, I'll enter 25,000 pounds per hour. Next, we'll enter the burst pressure. This should be the set burst pressure of the rupture disk. Again, a numeric value followed by a pressure unit of measure. By clicking on the arrow, you can see that there are several units of measure to choose from. Let's use 100 psig in our example. The next line is for the entry of back pressure, if any exists. Just like the burst pressure above, the first field is the value followed by the unit of measure. The next line is for the entry of the rupture or the burst temperature. This should represent the temperature in combination with the burst pressure at which the rupture disk is expected to burst. Just like before, we have 2 fields. First the numeric, followed by the temperature unit of measure. We'll keep it at 68F in our example. Next, we'll look at fluid properties. If you've selected gas as your fluid state, you'll have a selection of several common gases. Or if you've selected liquid, you'll see a list of common liquids. Choosing a gas medium will also show the corresponding values for ratio of specific heats, molecular weight, specific gravity, and density. Or if you've chosen liquid, you'll see the values for density and specific gravity automatically filled in. If you're choosing a steam application, the only medium available is dry saturated. Now I'd like to show how we can enter either a custom gas or a custom liquid. In the drop-down list, custom gas is located at the very top. If I select that, we now have a custom gas description field that is visible. I'll type in custom gas for demo. The next choice allows you to pick either molecular weight or specific gravity as the known value. If you select molecular weight, you can enter the value for your gas, and the specific gravity is automatically calculated. Or, if you select specific gravity, the specific gravity becomes the entry, and molecular weight will be automatically calculated. In either case, the density of the gas is also updated automatically. For this demo, I'll just change the medium back to air. Let's check out the right pane where we can see the results of the sizing calculation. Since we are solving for MNFA in this example, Z-Size has calculated the required MNFA as 3.876 inches squared based on all of our information entered on the left pane from before. In the unit of measure drop-down, you'll see we can also choose centimeters squared or millimeters squared. The next calculation is simply converting the MNFA in area to its equivalent diameter. In this section called Enter Disk Specs If Known, we're giving you the opportunity to enter the MNFA of your own rupture disk, and Z-Size will calculate the resulting capacity. The calculation will use all of the information that was entered over on the left pane from before. If I enter 5 inches squared, the calculation result is 32,247 pounds per hour. Again, all of the drop-down fields for both MNFA and capacity give you the flexibility to see your results in the different units. The next line is where you can fill out some fields to use as a reference for your own disk size or model number. And finally, there's a field where you can add notes relevant to this individual sizing. I'll just type in PSE 234 in location 3, just as an example. Thank you for watching our video on Z-Size. Please contact ZOOK if you have any other questions regarding Z-Size or your rupture disk application.